Welcome. Welcome. It gives me a great pleasure to join Peter and the others in welcoming you here to this users conference. The voices that you heard were from previous speakers at the International Users Conference. They are leading scientists from around the world, and I hope you heard in their voices how very important they think GIS and also your work is to the future of humankind. I want to acknowledge Peter and all the great people at ARC Data, but also I want to acknowledge you and thank you for coming this afternoon. I have a very full agenda, and I'll go through it relatively quickly. But I want to start off by simply saying thank you and acknowledging you and welcoming you to this conference. Each of you, as individuals and also your organizations, belong to I would call it an international community of GIS professionals who are collaborating and working together to create geographic knowledge to support all kinds of endeavors, just about everything that we know about as human activities. They are addressing many of the challenges that the scientists who spoke so eloquently this morning about. They are the challenges of urbanization, of human development, of natural resource management, of making things more efficient, of improving the way that we make decisions in our institutions. Your work, and I really want to acknowledge you about this, is, I think, very important for the future. It's probably the most important community in the whole world. I'm, of course, biased a bit, but not a lot. The perspective that I have of meeting with many of you and your colleagues around the world gives me a special kind of insight to understand that you are building a knowledge infrastructure, a kind of new popularism of science in society, the application of science to virtually everything we do. Peter asked if I would share some of the work that's going on by your colleagues in institutions like he did about the work that you're doing here in the Czech Republic. These maps or examples show work that's going on in climate change, environmental monitoring, and assessment. And they range in scale from the whole world to microgeographies, from things like measuring noise or the noise potential impact from proposals to the idea of measuring what's happening with the biosphere at all scales. Your work in energy development is phenomenal. It's not only supporting the extraction of traditional energy and managing of natural resources from agriculture to forestry, but also looking at the renewable kinds of energy generation, wind, solar, thermal extractions. These beautiful maps show the work in land information, the foundation for the civil society, record keeping, systems of record about who owns what. But you'll notice from these examples the beautiful realization of pictures about valuation or the impact of land on environment, even now moving into examples of 3D cadastre. In the world of creating the future, GIS is very strongly placed in urban design, like here in Prague, in urban planning and regional planning, in green infrastructure planning, making cities more livable. And part of that is certainly transportation planning and management. These maps show a range of applications from public transit to walking to rail transportation, all the way down to getting smarter about knowing where there's parking availability. adjustment here. Sorry about that. The two maps that I'm most fond of in this display are the two in the lower center. They show postal delivery and also smart routing from a large parcel delivery company called UPS. The UPS deliveries last year saved $400 million by driving greater efficiency. This is greater efficiency in fuel usage, in traffic, in, of course, just time. And this is the great hope of GIS in transportation, that it makes things more efficient, that it helps us understand what's going on, like the example of traffic management in Germany, but also better plan for transportation systems that are more sustainable. In the world of utilities, GIS is being used in traditional asset management, like here with CEZ in the Czech Republic, but also for smarter approaches, smart network management, smart meters, and even 3D visualization for assessing the coverage of 4D coverage in San Francisco. GIS is moving to a more detailed scale. It's moving into buildings and campuses. Universities, corporate campuses are beginning to use GIS to better optimize room arrangements or people within rooms, supporting evacuation planning and just visualization of what could be. In the world of business analysis, it seems like geography has caught on. Businesses are getting the concept of the geographic approach, trying to understand their patterns of business. Like in the upper right-hand corner, this is the president of SAP looking at his sales, to supply chain or retail site selection, optimizing distribution, understanding demand for certain kinds of goods. Geography is catching on and giving businesses an advantage, which of course is better decision making, but also just greater efficiency. And business people understand this. In these maps, in these important issues of health and education and demographic patterns, we see users creating things like maps that show income equality, or the disparity between access to schools or access to health care. And the exciting maps that Peter showed this morning show the exact same pattern being replicated here in the Czech Republic. Last year, the World Health Organization helped shut down Ebola in West Africa using the geographic approach. And this year in the Americas, we see the spread of the Zika virus, which is having painful impacts. We're trying to get it geographically surrounded and managed in more effective ways. In the world of public safety and security, clearly GIS is making cities and regions more safe. And this looks at patterns of crime, trying to target where bad guys or bad activities are happening, but also looking at space-time, where we can look at not only patterns of crime, but also when they are occurring. And this example shows, I hope you understand, this example shows a new trend in GIS, which is not only visualization in 3D, but integrating the whole temporal dimension to it. Users are now preparing for and managing disasters, and this morning's presentation makes it clear that GIS professionals and their skills, the communication capabilities that they have, will be demanded as we move into a period of rapid climate change. The map on the lower right, in this case, is Hurricane Matthew, similar to the Hurricane Sandy that hit North America a couple years ago. This map shows not only where the hurricane moved, but it also showed a new phenomenon, which is crowdsourcing of information about where vulnerable populations are, the small little black dots in Florida. This combination of Red Cross workers volunteering information using crowdsourcing and NOAA's powerful climate pattern tracking and prediction brought a situation together that everybody could understand. It became a new medium for understanding. The world is changing. People are demanding more open data, more open access to their governments. They want to be more engaged. And whether this is in the political arena or whether this is in the scientific arena, governments are beginning to open up with open data delivery, and certainly the Czech Republic is distinguished in this regard. I'd like to return to this subject later, but there are now literally hundreds of thousands of geospatial data sets that have been published, and people are beginning to download them and use them in all kinds of interesting and unusual ways. In the world of cartography, GIS is making progress. We are learning not only to make our traditional maps, like topo maps, this beautiful set of maps from Swiss Topo, better, but also we're learning how to render everything from outer space planetary cartography to the poles. And well, I'm a basketball fan, not so popular here in Europe, I guess, but the map in the lower center is showing the shots. Are you guys understanding what I'm talking about? Basketball, you know, the ball that goes shooting, so it's showing a very famous basketball player's shots in the last year. The whole concept is that we can understand as a competitor and get the advantage. It's geography applied at a very different scale. The world of cartography is also changing. With story maps, these maps are a few examples of it, but with story maps, the internet is coming alive with a whole new kind of medium. Last year, almost 200,000 maps were published in this way, and tens of millions of views every day are exploring everything from science to politics to tourism through this new medium of cartography. All of these examples tell a story. Some of them are the science story. Some of them are attempts to create a better future story. Some of them show targets, like the maps of crime. And others just tell us about the basic way things are. Your work is exceedingly important, and I want to emphasize that again and again this afternoon as I describe it. And these examples, while perhaps you would say are unique, are actually not unique. Today's workforce in GIS numbers in the hundreds and hundreds of thousands of workers who take their work seriously, much like yours, and take the idea that they can take that knowledge and drive it to populations to make a better future. I want to focus in my presentation here about a vision, which is the vision of GIS enabling a smarter world, a world where decision-making is better than the situation that we have today. You and I are living in an amazing time, unprecedented really, and you know this as well as I. We are learning to measure virtually everything that moves and changes on the planet and connect those measurements in real time to the web and increasingly make all of that data and knowledge available to everyone. This is going to create a huge transformation. Well, some would say it already is. And your work, the work of mapping and GIS, is front and center for understanding that digital future. It's like a new language, a new way for people to understand. So many of you thought that you were GIS professionals, and that was your field. From my perspective, you're in the understanding business. It's fundamentally understanding context, but also content. And this dynamic between seeing the whole, being able to integrate the whole, as well as describe the pieces, is a remarkable profession. And it will increasingly become important as the world develops. At the very same time as this evolution is occurring, as we heard from the scientists this morning, our world is increasingly challenged, not just in your cities, not just in your country, but the world as a total. The challenges of climate change and exponential population growth and pollution and the kind of huge migrations that are occurring from south to north, the effect of that on social conflict, the political debate changes that are occurring in countries around the world. The evidence should be clear, ladies and gentlemen, that this is not sustainable. The arrows are going in the wrong direction, and the climate arrows are actually exponentiating, which is pretty serious business. And so I don't have necessarily a very positive view of the future. I think it's no joking at this point. I mean, I've worked at this my entire life, and I'm frankly scared about the future. Everybody wants to ignore it, say, oh, yeah, well, it'll work out. I want to take a positive view. On the other hand, it's not working out, is it? I mean, I don't want to alarm you, but if you read the newspaper every morning, it's like it's on fire, isn't it? Or am I some stupid idiot from California? I mean, well, I could be that also, but I just want you to get that the evidence is clear that what we're on is a pattern that's not sustainable. And so from my perspective, that's going to require every bit of energy that we have, every bit of knowledge, every bit of critical design thinking, like we heard this morning from in the world of water resources, designing more livable and sustainable cities, designing more sustainable agriculture. Everything, every aspect has got to very quickly react to create a sustainable future. Or maybe you and I will live through this. Actually, we won't live through it. We're going to die. But the children of you and their grandchildren, it's not a pleasant future unless we do something now. And so this is not a new conclusion for me. I've been working at this a long time. I'm just getting more and more worried because from my perspective, we need to create a smarter approach. Now, from my perspective, the good news is that the work that you do, the GIS work, the science work, actually provides a framework for approaching the world and our cities and our organizations holistically. Let me articulate it clearly. GIS provides us a framework for integrating all of our data. That's very important. So we break down the barriers between our various ologies, geology, sociology, economics, archaeology. We can bring it together with an integrated data set, reading in the Internet of Things. GIS gives us a platform for communicating, for visualizing, for informing, like the beautiful presentations we saw this morning by the weather forecaster. It also provides us a framework for analytics and modeling, like we saw in geohydrology, looking at all the patterns and relationships so that we could bring it all together and model what the future would be. GIS is also a framework for us to be able to design different alternatives and evaluate the consequences of the alternatives. Building high-rise, what's the impact on traffic, what's the impact on water pollution, et cetera. And then GIS is able to communicate to people so that they can both individually and collectively make better decisions. And also, GIS is a framework for acting. This is not only going to change behavior, it is not only changing behavior, but it's also the means to give directions, targeting, navigating to a better future. So, ladies and gentlemen, this is a very important slide to me. I think it brings together all of what you do. You may not all do all these pieces, but you are certainly pieces, you are certainly playing into this cycle of a framework and a process to create a smarter and better future. I want to now move on to what's actually happening in the concepts of our technology. We are moving from desktops and servers to include what I call a system of systems, a WebGIS. And a WebGIS is opening up access to the data. It's opening up and simplifying with browsers and devices and mobile access to information. It brings together distributed servers and services and amplifies it out to everyone. This is the great hope that just like Google Maps keep people from being lost anymore, I mean, people don't get lost anymore. I can use my Google map to find anything. Or I understand there's a similar technology here in the Czech Republic. We want GIS to be the guidance system so our planet doesn't get lost, so our organizations don't get lost. This is the great hope. And I think for the first time, we now have an architecture with web services and a platform that can be a system of systems that can bring our collective systems together to be able to support a more sustainable future. Well, GIS itself is getting smarter. What do we mean by this? First, it's integrating and leveraging many types of innovations, faster machines, GPS, multi-dimension, 3D, 4D, time, space, integration, new types of measurements like LiDAR. All of these things are coming together in a new generation of services-based GIS. Specifically, there are 5 things I want to describe as a smart GIS. Because you might say, what does smart mean? What do people mean when they say smart cities or smart futures or smart utilities? First, it means being able to operate in real time. So with the emergence of the Internet of Things, you actually have the technology to bring in real-time data, spatialize it, and integrate it into the same analytic and visualization system that you do with things like geology maps. In my country, already real-time GIS has come alive with real-time dashboards or control rooms, like this dashboard of FEMA, our Federal Emergency Management Center. Everybody in the United States can access these web services, including control rooms, taking sensor networks of water or climate or traffic or where people are, analyze them, overlay them, and visualize them like the Seattle Police Department in the center picture. This is showing up in many fronts. This is a brand new technology connection between Waze, the traffic people with crowdsourcing, and GIS people. Today, you can make a partnership with Waze to bring in their real-time crowdsourcing data on traffic if you simply share your data to the Waze organization about street closures. It's a beautiful kind of real-time back and forth on the web partnership. The second definition of GIS is that it is connected to people. It's a system of engagement. It's not just the system of record keeping or even the system of real time, but it's a system connecting through identity and, like in social media, every individual in an organization. People can collect data, share data, connecting people with their organization, with the community itself. And a common language, the language of maps, becomes the conversation. The third definition of SMART is analytics. Smart GIS enables new kinds of analytics. Here I present three. The traditional spatial analysis and geoprocessing, as was shown in a couple of cases this morning, supporting traditional modeling. But two new kinds of technologies are emerging. One of them is interactive exploration of data, and the second is big data analytics for the hundreds of millions or billions of observations. Both of these have great meaning for the future. Both of these kinds of technologies are emerging this year. The exploratory spatial analysis is a new tool. Actually, it's a new tool that's coming out in a few weeks called Insights. This allows us to drag and drop data like spreadsheets or enterprise databases onto screens and work with spatial analysis in ways well, it's just amazing. I can sort of describe it, but you won't understand exactly what I'm talking about until you actually see it. So I just have a couple of minutes video that I'd like to show right now so you get kind of a sense of what it is. Could you roll that video for me now?
Insights for ArcGIS is a new experience that we're introducing into the ArcGIS platform. It's a new way to explore your data, to ask questions of your data in new and unique ways. Insights for ArcGIS allows you to solve spatial problems in a very interactive and intuitive way, very drag and drop, visualization friendly style way. If I can think about it, I can do it. If I can click on it, it'll happen. And it's not just about one powerful map. This is not just about a map. It's also smart charting and smart analysis.
The great thing about Insights is you can bring data in from anywhere, whether it's an ArcGIS Online, whether it's an enterprise database. The idea is that Insights is the place where you bring your data together to generate understanding. It's very easy to get data onto the page. It's as simple as drag and drop. And depending on the thing that you're dropping, you're going to get different types of representations. You might get a map, you might get a chart. The idea is that these things are linked together. Because this is the same data set, I can explore relationships. For example, I can click on one of the bars, and those points are highlighted instantly for me on the map.
So we can modify all the information that we have on a card just by simply dragging and dropping the attribute that we're interested in. So now we're seeing that aggregated by a fence type. Or I can drag across a standard geography, summarize that, and we're seeing that information summarized into my zip codes that I have. And of course, at the moment, we're working with small cards. I can expand that card so that we can get a more detailed view of what we're looking at.
We're looking at a lot of data here. These are the crimes in Washington, D.C. But let's look at them on different dates to see if where crimes happen changes. It sure does. But we still have a lot of different data points here. So let's look at this as a heat map. By clicking through, you can see that the heat map changes. What we can do is use the heat map to not only understand the density, but the linked time series graph to show how these patterns change over a 2-week period. So we've been able to bring a lot of data into our page, but let's run some analysis so that we can generate some understanding of what's happening here. Let's run a 1-mile buffer around these police stations in Washington, D.C. Now let's drag the crimes into these buffers to understand if the total number of crimes changes relative to the position of the police station. And it sure does. You can see some police stations have a lot of crimes occurring within the 1 mile buffer.
So we can filter between the different cards. So let me drag and drop the number of people who are working into the data set. And now you see I get a histogram. I can change that so it's completely flexible if I want to change the number of bins. But now I can select from my map based on the frequency in that. So let's have a look at the number of vacant properties within the area. And let's see how everything automatically interacts together. And of course, that's not something I had to set up. It's just going to do it automatically for me.
One of the things we often need to do is filter our data. What we can use is a page-level filter using this histogram to decide what parts of the data to include and which ones to exclude. Insights automatically creates a web model for you while you're doing your visual analysis. By turning the page over, you can see the model and you can adjust the parameters. Why does this matter? It allows me to share my knowledge with the world by sharing the model, and I can bring the model into ArcGIS Pro if I want to further enhance it.
By slicing and dicing our data in different ways, we've revealed different information. We've seen that the educational attainment and the white population have a very similar pattern. We've seen the patterns across the diurnal changes, so whether there's crimes at day, evening, and past midnight. We've seen the temporal patterns in the data, and we've seen that by the different crime types. We've also seen correlations within the data. We've seen police stations are located in good places across the city. And all we've done is explored that one data set in lots of different ways.
Good. So you get an idea of this? It's a different kind of GIS. It isn't desktop. It's just in a browser. I don't need a lot of training. I can just begin to drag and drop and explore my data. Spatial data exploration. And it complements our traditional spatial analysis and geoprocessing. Over on the left is yet another kind of spatial analytics that's coming very shortly, which is the ability to analyze very, very large data sets, like in a very short amount of time. In the top, we see all of the lightning strikes for the last 5 years being able to be analyzed in a few seconds in a big data environment. Or on the bottom, we see a 40 billion pixel raster data set being able to be overlaid and processed in just a few minutes to pick the best location for solar energy farms. These kinds of tools can be accessed just from the desktop or from a browser in ways that will just change our ability to approach problem solving. A few examples of these smart applications or approaches are shown here. On the far left is a new app for earthquake alerting. You may not have that here, but in California we worry about it a lot. So if an earthquake happens in San Francisco, about 500 miles from my home, I can be alerted maybe 60 seconds in advance of the quake actually hitting the Southern California region. It's a smart, consumer-facing, new kind of app. In the middle is a model generated by NOAA, the people who run the weather satellites. The rainfall is now forecasted 5 days and 10 days and 15 days out. We see that by the reports on the television, what's coming when. But this model in the center puts that together with a digital terrain model so that we can forecast 5 days or 10 days or 15 days out when the flood is going to hit, for example, in central US. This will change emergency management because we will know what's coming. On the far right is the integration of social media. So in the city of Cambridge, they're now proposing different transportation sites or buildings and allowing the community to vote using Twitter and other kinds of social media about these proposals, a new kind of open government interaction. Another definition of smart is smarter planning, the ability to integrate all the different kinds of data together and then interactively work with that data to generate geodesign alternatives, like urban design alternatives, this example in Singapore, or urban planning alternatives. What's the impact on transportation? Or green infrastructure alternatives, transportation alternatives, etc. Bringing all the web services together from multiple agencies and organizations and allowing us to sketch and envision the future. This small example here is in Hollywood, California, where multiple alternatives are quickly sketched and evaluated in terms of money, environment, impact on transportation, etc., impact on tax base for the local government. The final thing I'm going to mention about SMART means meaning engaging the community. And this is a trend that's going on worldwide. Engaging the voice of the community. Traditionally, we've had GIS for individuals. You might think of it as a desktop. We've had GIS for work groups, maybe in a department. We've had GIS for whole enterprises like a city or a utility company. This is the next logical step, which is GIS for the community. This is the next step beyond open data. In the city of Los Angeles, for example, almost all of their layers of data has been put into an open cloud environment with services, map services and analytic services, so that citizens can actually enjoy playing with, working with GIS. Citizens, non-governmental organizations, kids in school, or in Los Angeles, startups. The city of Los Angeles took most of their urban data and put it out in the cloud with this services environment so that people are now able to do GIS from anywhere. The millions and millions of people that live there are starting to mash up and do analysis like professionals would be, and also give feedback back to the city about issues like trash cleanup, broken roads, broken lights. So it's engaging the community in coming out with the solutions and problems and plans for the future of the city. And it's also, in Los Angeles, resulted in creating new businesses. There's about 36 new startups that are taking the city's data, creating new solutions, selling it back to the city. This upset some of the staff in the city. They said, well, we could have done that. And the mayor said, why didn't you? Well, this is a way to free up the data and these services, and new innovations are coming out of the sky. This is a new way to leverage the investments in government GIS. The way they did it is they took different departments, serverized the data, built an internal GIS portal or hub so that the different departments could use each other's data. This saved them a lot of money right away. Then they took the data contents, some of the contents, and the portal and put it outside the firewall in a cloud system. And the citizens and startups and journalists and developers are using the same system, providing feedback back to the city around urban initiatives. This idea is intriguing because if we look at the pattern of web GIS and services, it means that we can approach GIS architecture in new ways. We all know, coming from individual desktops and doing individual work was transformed when the desktop became connected to a services environment. Organizations were able to approach problem solving across the organization. This will, I believe, evolve into organizations serving and sharing each other information. I first got this idea in the city of Los Angeles. I went to the Public Works Department, and a young man was updating a water map, and he was changing and adding some lines, and there was a parcel map behind it. Well, I know Los Angeles quite well because I worked there a lot. And I asked, what is that parcel map? Is that the planning department's parcel map or the engineering department's parcel map? What are you using? He says, no. Los Angeles doesn't have any parcel map anymore. I said, well, where is it coming from? He said, it's coming from the county as a service. Now, the county updates the parcel map 150 times every day. That's extraordinary. I said, you mean the millions of dollars you have spent on parcel maps you're no longer spending in the city? He said, yeah, that's right. We saved all that money. And now we just bring it in right real time, and we have it ready to use. Isn't that a neat story? I mean, I started to think, okay, where's this going? Geology maps, water maps, vegetation maps, remote sensing maps will be served, and people will be able to mash up each other's content dynamically. That will create a kind of nervous system or a platform for the Czech Republic, or for Europe, or for the planet. We are in the understanding business, and the integration of geographic services analyzed, you know this better than I, will become a platform for a smarter world. My sense on this is that humans have actually never been more capable with this services model of both sharing their knowledge, but also connecting, understanding, and ultimately acting to create a better world. And you, ladies and gentlemen, I think, I want to send a strong message that transforming your organization, whether it's a utility company or a water agency or a planning organization, needs to embrace the big challenges that we heard about this morning, climate change or congestion in cities or social conflict or saving nature, and envision what's possible and use these sort of new technology types to be able to share and collaborate to come up with better designs for a better future. I think that is the basis of what I wanted to cover this afternoon about creating a smarter world. Now, how do we do this technically? I'd like to talk about, during the remaining few minutes of my talk, what we're working on at the lower level, actual practical tools. And there's a lot. My colleagues and I spend hundreds of millions of dollars a year in evolving the base platform. And the base platform is ArcGIS, the technology that most of you use. This is our vision for ArcGIS 10.5, which most of you will be receiving in just a few weeks. It's a complete web GIS. It's no longer simply a client-server GIS. It's built around the concept of services. It's a complete system for managing and analyzing and applying geographic knowledge. It's completely deployable in the cloud, if you guys have a cloud. It's completely deployable in your own premises. And it's designed to support an individual, but also work groups, organizations, and ultimately the community. And I think that last step is where this is going. This platform supports three main types of GIS. The first type is one that's very, very clear to all of you, the systems of record. The records about cadastre, the records about pipes, the records about geologic records, the records about water. The second type of system is the system of engagement. And most of you know what we mean by engagement. It means identity. I'm Jack, and therefore I have privileges to access content behind it. And the social media kinds of systems like Facebook are best to describe what I mean here. And the third kind of system is this system of insights, the analytics. Now, those of you from the IT world, you'll know that traditionally these three kinds of systems are typically separate. There's the systems of record keeping, the Oracle database or the SAP database. There's the systems of social media that connect and interact with. There's the systems of business intelligence, or BI, the systems of insight. These are usually three separate systems. What we have accomplished in this engineering is that these three systems operate in tandem. They're actually one system, so that updates in the system of record are immediately enjoyed in analytic environments, that analytics are immediately available for insight, and so on. This system has been designed to be open and interoperable. In this room, we probably would have 200 or 300 definitions of what open and interoperable means. The way that we look at this is multiple pathways to ensure that the technology is open and interoperable. One is with support for open standards like OGC standards or WWW standards or ISO standards. The second pathway is to build direct product integration between ArcGIS and other kinds of technologies like AutoCAD or like Adobe or like Teradata or SAP HANA, so that it doesn't have to be integrated, it just works, two COTS packages plugged together. And the third one, the third definition is really work in the world of making our software open. This means open APIs, well-structured, extendable architecture that's embeddable, open access to the data, open sourcing major components of the software, and integrating with other open software like R or other scientific packages. The evidence that this actually works is shown in the fact that we have implemented thousands and thousands of systems that are complex and heterogeneous, the ArcGIS platform. ArcGIS is evolving, and this last step, version 10.5, makes a series of significant changes, and these are worth noting. We're moving from supporting not only client servers domains to web services and apps. This is a big change. From standalone desktop to desktops which are connected and hydrated by services. From concentration on data models to concentration on the design of web maps and web services and layers. From moving from a single server, single source, to multiple distributed computing, so I can ask big data questions and have it compute for me in very large and scalable environments. We're moving from custom applications where we have to write everything to apps that are easily configured, and from proprietary data to open data, from 2D features to 3D features, from simple spatial analysis to space-time analytics and big data analytics, and from using the computer to help me make computer maps to the idea of the computer through computational work. AI basically can help generate maps automatically. This is embodied in a whole series of capabilities I'll move through relatively quickly. Let's start with data management, the heart of a GIS. Here we're making improvements in editing, in supporting new version models, adding vertical data transformation, and introducing a whole new utility network. Also integration, close integration with HANA and Hadoop and Elasticsearch. Second, complete support for field GIS. This means applications for the mobile workers, for workforce management and navigation and data collection like Survey 123. Connecting these field workers with the enterprise office so that as they're doing work, the enterprise central headquarters is always up to date. very powerful for spreading GIS across the whole enterprise. We're adding new tools for making map making smarter. Smart mapping means computer-assisted rendering styles, both in 2D and also in 3D. At 10.5, we introduce vector tiles across the entire platform, which have huge implications for multi-scale cartographic rendering and more flexible rendering. In the spatial analytic areas, I've already made reference to the big data tools that connect big data servers to the desktop. But also, there are dozens of new analytic tools. I'll just pick out one, which is the exploratory Bayesian Kriging regression tools. This is really heart and center for computational derivation of relationships, the sort of machine learning of about things, how things are interrelated. But there's many other new tools coming. 3D is now implemented across the platform, just like 2D has traditionally been. This means complete web 3D. It means looking at the whole planet with technologies like the Google Earth technology, now ArcGIS Earth applications. We've enhanced the ability to support point clouds so that we can look at 50 billion points in LiDAR clouds and easily navigate, classify, and derive results. In the world of imagery, historically there has been image processing systems and GIS systems. Our work has been to bring these two together. So one platform now supports with ArcGIS hundreds of imagery and image analytic tools. New advancements here are the linking of drones to the ArcGIS system. So I can buy a €1,000 drone, fly it, and in an hour or so produce orthophotos fully automatically that I can load into my WebGIS as services. This will change things because this isn't just rough picture taking. Our US Army Corps of Engineers is using this because it's giving them 2-centimeter accuracy from their drone flights on specific projects. GIS is opening up with a whole fleet of apps. ArcGIS apps for the field, like Survey 123 or Collector, I've already mentioned these, but also Office apps like Microsoft Maps for Office, or Esri Maps for SharePoint, or the new Insights application that I showed you, browser-based exploration, kind of GIS for everyone. And then community apps, crowdsourcing apps. I can use new tools to be able to ask the crowd to tell me what's going on and have that pipeline directly into my GIS for immediate use. What's fueling these app revolutions are not only the configurable apps, but also something called Web App Builder. Today, over 500 new apps will be created and shared in the open web, and that is exponentially growing. With the introduction of App Studio earlier this year, it means that I can write an app for my iPhone and recompile it in my Android device for immediate distribution to users. This will open up your work. This, together with apps like Story Map Telling, will provide access not only to everyone in your organization, but the community in total. Behind this, we have worked hard on making sure ArcGIS is developer open and friendly. Here we're making major improvements in 3D by introducing at the runtime level 3D everywhere, but also a new application called a Python API can access the entire body of knowledge in ArcGIS through Python scripting. And I'd like to point out the little orange hexagon. This is a new site introduced last summer, which is an open source sharing site with thousands and thousands of contributions by our users trying to help other users through sharing their code. I'll conclude with a couple of slides showing how all this capability is coming together in an integrated system. ArcGIS is one system, just like your iPhone has an iCloud, has iMusic, has iApps. It's one system. You buy a phone and you get a whole ecosystem with it. Likewise, ArcGIS has apps, it has the desktop, it has online, and it has server. These are all integrated into one environment. They're not just a desktop here or a server here. They all work together and are synergistic. In the desktop world, last year we started introducing a new desktop, ArcGIS Pro. In a couple of weeks, we will release ArcGIS Pro 1.4. This will replicate virtually all of the ArcMap functionality in a 64-bit environment, and lots of new tools coming there. ArcGIS Online continues to march along. It now has over 3.5 million users. It makes about 500 million maps a day. There are millions of data sets that have been shared by our users, helping users, and new apps and so on. There's more content coming here, global imagery, and other apps that make it more exciting. The third leg of the stool is ArcGIS Server. At 10.5, ArcGIS Server completely includes all of the technology of ArcGIS Online. So you can set up your own ArcGIS Online inside of your own organization. It is not only smarter, it's also easier to administrate, and it's scalable, so you can have almost an infinite number of cores to support large computational problems. Finally, with ArcGIS Server 10.5, we have the concept of portal replication. What this means is I can have distributed servers which have portals about the metadata, and the portal data is replicated into a portal of portals so that I can have true enterprise GIS across my organization. Also at 10.5, I can replicate the content to an external, outside the firewall, portal and GIS, like in ArcGIS Online. This means I can enable this community GIS to emerge. And believe me, ladies and gentlemen, there are hundreds of local governments that are already starting to get their data together to be able to support that. I believe it'll be the next big step. All these improvements that I've been talking about are in 10.5, and I'm excited about it. I think it's probably the biggest release by far of technology that we've ever made. It responds to these lists. First, it's a complete services-based system. It's enterprise-ready, meaning I can take my entire city and serverize it and build an integrated platform for everyone. It has these new analytic capabilities like insights and the big data stuff, better image services, 3D everywhere, and many of these apps that I can freely disseminate and connect people from it. Most of you, I suspect, are ArcMap users. 10.5 actually represents the first time Pro fully integrates the ArcMap technology. I want you to learn these tools because they're very powerful and will change, I think, the pattern of how you do GIS in your organization. We have a rich roadmap coming into next year. These are a list of some of the things that we are continuing to work on. 10.4 was released at the beginning of this year. 10.4.1 was a bug release, and 10.5 will be this very major release at the end of the year. I wanted to say Esri is doing very well. We continue to grow. We continue to keep our attention on you, our users. One of the reasons why I very much appreciate coming to these user conferences, people give me lots of ideas, and my colleagues like that because it actually drives the evolution of our products. So I want you to engage with us in various ways. Our focus continues to be on science and engineering of a product that can ship in volume and support your needs. We also work very strongly in the educational sphere to promote GIS literacy, particularly in the K through 12, but also in higher ed. We're also working to make a difference. We ourselves don't get that opportunity so much, but we see through our work with you what very powerful things are possible here. I'll conclude by simply saying getting smarter means different things to different people. All this new tech is about integrating real-time and powerful analytics, and it means that we're going to be able to engage everybody in organizations. But the science part and the technology part and even these neat tools that I'm sure you'll enjoy are not enough. Part of the reason why I enjoyed what Peter did this morning of putting up front the large challenges that are facing all of us is that to address those kind of challenges, it's going to take not just you as individuals, but working together and engaged and committing to supporting our colleagues in the planet to create a more sustainable world. Thank you very much, ladies and gentlemen.